Take care. Bye.
Thank you.
You too. Bye.
So hello everyone again. We'll start, and yeah, feel free to ask any questions. Maybe we can wait for the end of the presentation for any questions, and I'll try to be short with the presentation, but share enough useful data, of course. So I'll tell you the story about my company that is basically 100% serverless startup. I'll not tell you a lot about the business problem that we are solving. I'll focus mostly on technical challenges that we had building this startup. It was one of the early startup, 100% serverless startups. So we learned a lot during the way. We started basically with one Lambda function, and Lambda function is basically a serverless function in AWS. Instead of writing like a big monolith application that has everything on some server or something like that, you write like a single purpose function, and then you attach some trigger to that function. So we started with one Lambda function, then added another and another, and quickly that like evolved a lot, and now we have 100 functions in production. So we'll talk about that now, and I'm sorry, I'll stop from time to time to admit new people. Oh, come on. So in 2016, we decided to build the leave tracking system because that's something that we needed at that point. As we worked in, we have another company that is basically consulting business, and we needed some way to track who's taking vacations, who's on a sick day, and things like these. We tried to find some product, but most of them were too complex for us or too expensive at that point. So we did some internal hackathon, built some really, I don't know, prototype of the application that never worked. So we decided not to do anything there. And of course, a year later, we tried to solve our problem again. And what we did, we basically just built, again, a prototype of some Slack chatbot because we used Slack, and then we stopped there. And in 2018, we finally decided to really build this application because we published some landing page, and we had like 100 people waiting for our beta application that we never built. So we decided to do something about that. And the idea was really, really simple. We wanted to build a application that will track leave requests and number of remaining days. We'll use some single sign-on, such as Slack or something like that, because we don't want to remember more passwords. It's boring thing to do. We wanted to connect this application to Slack because we used Slack at that moment, and we are still using Slack, and we wanted something integrated to tools that we use every day. And finally, we wanted to integrate like everything with the calendar and subscribe to some kind of events and see who's off and things like this. And of course, as I said, we were solving our own problem, and we didn't know if anyone else will use that app. Soon after that, when we finished the first version, we started seeing like startups using our app, and then some small companies, schools, nonprofit organizations, some teams from enterprises, government organizations, and believe it or not, churches. And we have like, I think, 20 churches paying for our product now. And there are some big companies using our product, but that's really not important for this application. The number of unique users that we had in our system in December was like 250,000 or something like that. Now it's more than that, but again, that's not that important. So I'll show you the product quickly. So there's some web dashboard, there's some chatbot in Slack where you can request or approve leaves. There's the same thing in Microsoft Teams with some embedded web application and many more things. And so let's dive into the most important, interesting things, and that's architecture. So the first version was a simple serverless bot. And it worked something like this. At that moment, Slack didn't have calendar, so we built like a calendar inside our app. And there was some serverless function in the background. Whenever you click on a button, some Lambda function was like running in the background and doing something. And why serverless? Well, that's the topic of our talk today. So I'll talk about how we came from 1 to 101 Lambda functions and even more now in production, and how we evolved our serverless architecture. And before we continue, let me introduce myself. I'm Slobodan Stojanovic. I'm CTO and partner at Cloud Horizon. That's that's the company that they mentioned in the beginning. So we try to solve our problem in Cloud Horizon with basically the other product that we have, which is Vacation Tracker, the other thing that I mentioned. I wrote a book about serverless applications with Node.js with my friend Alexander Simovic. I'm also AWS Serverless Hero, and you can follow me on my blog and of course on Twitter. So why serverless? Well, if you talk to people, serverless, they often describe serverless as something slow, expensive, or whatever. Vendor lock-in is, again, something that they often mention. And of course, I'm just kidding. These are not really things why we picked serverless. We picked serverless because we had a really small team without any DevOps experience when we built the first version of our product. It's still a small team. We have just 3 full-time developers right now. Serverless is really auto-scalable, and the great thing with serverless is that even when we have like thousands of requests, it will scale automatically. I don't need to do anything, and we had like basically 100% uptime in last 3 years without like doing anything special, just by deploying everything to AWS. With the right architecture, serverless is really cheap. I'll show the numbers a bit later, but it's insanely cheap. So our infrastructure costs us less than 1% of what we're earning every month, which is really, really cheap. And it's really fast to build a prototype with serverless. It took literally just a few days to do something like that. And it's also secure because all of these Lambda functions are running for like less than 100 milliseconds or something like that, and they're basically, they have just a small part of the disk where you can write something in temporary directory, and everything else is read-only. So it's really secure, and AWS and other providers are making that secure for us, and it's really cool to apply these things now when we came to some kind of certificates and things like this. So our first application wasn't really 100% serverless. I built a quick prototype in Slack, and that Slack talked to something called API Gateway. API Gateway is basically a RESTful API on service for RESTful APIs on AWS. And that API Gateway simply ran our bot function. And then our first developer that was assigned to this product in like 3 years ago, he knew Express and Node.js and MongoDB, so we decided to build the first version in Express and Node.js. So everything worked like whenever there's something, some request from Slack, it goes through that API gateway, just like a standard API, triggers some Lambda function that do something with the bot. And that Lambda function talks to our MongoDB. And then whenever you use our web application, it goes through a standard like Node.js and Express.js application that talks to MongoDB. That part was at, I think, DigitalOcean at that moment. And the benefits, well, it was really quick, and we had really quick and independent deployments. Whenever you wanted to update the bot, it was like updating that one function, and it took like, I think, 30 seconds or something like that to update the application. It was easy to understand and maintain this kind of application because it was really easy to draw every part of the application. It was easy to onboard new people because, again, it was easy to understand what the application is doing. And it was really cheap. And when I say cheap, it was basically $0 for per month on AWS, because with Lambda functions and API gateway, first million requests are free every month. And in the beginning, we had less than million requests. And the cool thing is that even after that million requests, the next million is like 20 cents for Lambda. And now I think $1 and something for million requests on API gateway. Adding new features, well, we decided to build, as our developer started learning AWS a bit more, we decided to build more features as more Lambda functions. And then we had the first challenges. How do we know that some things should go whenever, for the bot, it was easy. Bot was still talking to API gateway and then to Lambda functions, and we included Stripe because we started billing for our service. But for the API, some routes were going to like Express.js application and some routes to new Lambda endpoint. So we put API gateway as some kind of router in front of both applications, and it decides where to send that request, to the old Node.js application or maybe to a new API endpoint that was fully serverless. There were some downsides, of course. We had independent deployments, which was like a big benefit in the beginning. But after that, with more and more Lambda functions, that became really complex to maintain. It was hard to manage that because whenever you wanted to start up a new environment, you need to like deploy all these different Lambda functions. So it was really hard to do that. It was hard to scale, not because of serverless part, but the rest of the app wasn't serverless. So we had like one instance of DigitalOcean that we somehow need to scale from time to time. And also there's that MongoDB database that sometimes we had too many requests on Lambda functions, and then our Mongo instance wasn't able to serve all of them. And we had a clear bottleneck, which is basically that non-serverless part of the application. At that moment, we had like 100 paying teams, and we decided to build a new version of the architecture of our app. And that's basically a complex serverless application. And the first thing was introducing something called infrastructure as a code, because instead of deploying one by one these Lambda functions, we needed some way to like describe our infrastructure, and then some tool that will just easily deploy all of these things. We started using something called AWS CloudFormation. And then we had kind of microservices. Each microservice had its own API and some Lambda functions. And all of these things were defined in some CloudFormation template. And of course, these things were like independent. So whenever you want to do something in one microservice, it can talk to another microservice somewhere in the background or something like that. But if the other microservice is not there, the first part will still work without any problems. And this is, for example, one part of our application. Now, instead of having like the simple thing, which is basically API gateway and one Lambda function, whenever you send a Slack message, we try to introduce something slightly more complex, not because we want to have more complex things, but we hit some limitations. For example, for Slack, whenever someone sends a message, you have 3 seconds to answer that message, or that webhook will expire. And 3 seconds is not a small amount of time, but sometimes there are some things in the system that needs more time to do some calculations and things like these. So what we did is basically building a small Slack integration app that has its own API gateway and different Lambda functions for different actions. For example, when someone types /vacation, we are triggering one Lambda function, and when someone clicks on a button, it triggers another Lambda function. And instead of doing a business logic there, we introduced something called Amazon Event Bridge, which is basically some kind of service event bus. So we published all these events there and immediately answered to Slack. Then there were some other Lambda functions with business logic that listens to different types of events and basically do some business logic and return the answer to Slack. At that moment, we had more than 150 Lambda functions, and we started doing first migrations, not from AWS to some other provider or anything like that, but from old services to new ones. And the biggest challenge at that moment was finding a good architecture that will allow us to continue evolving this application. Things we changed at this point were basically everything went into that infrastructure as a code called CloudFormation. Now there are some even better options called, for example, CDK Cloud Development Kit, which allows you to write your infrastructure in TypeScript and test that easily and things like this. You don't need to learn YAML and things like these. We replaced Node.js Server with serverless services. And it took a lot of time to do that, of course. We added TypeScript, and now our application is one big monorepo that shares code between front end and back end and things like this. And we finally replaced MongoDB with DynamoDB, which was probably one of the biggest transitions that we did from the beginning. The benefits were clear. So we had independent deployments. At that moment, we were able to spin up a new environment in like less than 10 minutes or something like that. So every developer has their own environment. We have another environment for testing, for, I don't know, staging, automated tests and things like this. So environments became really cheap for us, because if no one is using services on serverless, they're basically costing you $0. So it's cheap for us to spin up another environment from that point. It was still auto-scalable, and it scales really, really well. And that, as I mentioned at the beginning, we still have almost 100 uptime out of the box without doing anything on our side. The only downtime we had was basically something that we break during the deployment until we do a rollback or something like that. But that was happening really rarely. And it was really still cheap at that moment. There were some downsides, of course. At the moment, we were storing state, not events. And that's a big problem when you're doing like a kind of application where many things can change at any point. So for example, we'll discuss that later, but your days can change at any point. Someone can change your quota and things like this. We were wasting time on less important things that were not really our business logic. It was hard to onboard new developers at that moment, because CloudFormation wasn't easy to learn, and there are a lot of Lambda functions and everything, so it wasn't easy to onboard new developers, and we introduced many new services, so that was a bit scary for new people. And of course, we saw that developers don't like YAML, and we mostly have developers, not really DevOps people and some other people that can manage the infrastructure. At that moment, we had like more than 600 paying teams. So we were earning some money, and we realized that we really have a product that people want to use. So we decided to evolve our infrastructure one more time and build some kind of event-driven system. So we tried to find a good architecture for us again. We stopped with CQRS, or command query responsibility segregation. It's a way, it's basically event-driven architecture that helps us a lot to manage some of our big problems. So why CQRS? As I said, we were storing state, not events, and that was a big mistake, because let's say that we have this scenario. Anna created a location and moved John and Mike to that location. Then Anna assigned Mike as an approver. Then Anna assigned a leave policy, 20 PTO days per year, to that location. John requested the leave, Anna approved that leave. Then rollover happened. Some unused days were transferred to the next year. Then Anna changed John's working week. Then Mike added some past leaves for John, and then Alex transferred John to another location with different policy. And the quiz question is how to calculate John's remaining PTO days for 2021. So it's almost impossible if you have just the state, not the events. So we transitioned to events, and that helped us to have basically a log of all events that happened, so we can calculate the state from these events easily. We also introduced something called GraphQL, and there's a service for that on AWS called AWS AppSync, which is basically fully managed GraphQL. So here's how everything works now. Whenever you do something on our application, that's basically a mutation or some event that happens. That event goes to some kind of event storage table. That's DynamoDB table. DynamoDB is it's a NoSQL table from AWS. It's again fully managed, and you pay only for used capacity and things like these. You basically, if you don't have anything in the database and no one is using your app, that will cost you $0. Then we have some stream from this event storage table through some Lambda function to again, the service called Event Bridge, which sends some events somewhere in the background. Then our business logic do something with events. And because all of these things are asynchronous, and it takes just like less than like half a second to do this round trip through like event storage to event bridge and finally to finish business logic, but it's still asynchronous. We want somehow to notify our front end that something happened. And to do that, we are using GraphQL subscriptions, and browser is connected to these subscriptions. Basically, we are WebSockets, and whenever that happens, we'll let browser know that something happened in the backend. And finally, we also calculate the new state in some read-only table. We have actually a lot of these read-only tables, and whenever the client wants to see how many days do they have and things like these, they basically just need to send a query through that GraphQL, and we'll read the data from the read-only table. Today we have like 126 functions, so less than we had before. And the number is increasing a bit because we are adding new integrations and many other things. But when we migrated from from the previous version to this architecture, our number of our Lambda functions dropped by half or something like that. Benefits, we have fully managed GraphQL. So we don't have code that, we don't think about things that we thought about in the previous version of our application. It's fully managed, so we don't need to scale it or do anything like that. But we also removed a lot of Lambda functions. We allow GraphQL to do some kind of validations and write some data directly to DynamoDB. Of course, we have some strict rules who can write what to which part of the table and things like these. We have less code. We deleted a lot of code. We have much better control now over everything. And we have all benefits from the previous architecture, of course. And now we have a big mono repo where we share code and the types between front end, back end, chatbots, and things like these. There are still some downsides. There's even more new services to learn. And it's much easier now to onboard new people when they learn some of these services, such as GraphQL and things like these. There are velocity templates, which is some language. It's basically a templating language that allows us to talk from appsing that GraphQL service directly to database and other services without having Lambda functions in between. It's really not the prettiest templating language that you saw, and it's a bit hard to test, but we managed to find a way to do that. And we're really happy with our architecture today, but there are some big challenges, of course, that we faced over time. So one of the big challenges that I mentioned is onboarding new developers. Current team is basically 4 developers. And we have one new person that we hired like a month and a half ago. One marketing person, one person in customer support. We are hiring another one in customer support, and one product manager. And we have some freelance support for marketing and design from our other company. So it's a really small team. The cool thing is that the first day our new developer joins the team, they get their own environment, and they have their own AWS account where they can do whatever they want. And the cost of the system is really, really cheap with all these different environments. As I said, the architecture is now like one big mono repo, but we have a few different separate apps in that mono repo, and this is just how everything works. This is the GIF that you already saw, just a bit with a bit more details. So we have dashboard, Slack bot, Microsoft Tabs, like different applications talking to our GraphQL and writing events, and our API and writing events to DynamoDB that trigger some Lambda functions, and some notifications through Event Bridge goes to different parts of business logic, store something in read-only tables, and then there's that fake mutation that sends like real-time subscription back to our front-end application or whatever we need. And for new developers, for example, if they're front-end developers, we're trying to hire like full-stack developers, but every time some developer is more front end or back end. If they're front end developers, then we start, for example, with dashboard, which is a simple React application, and then slowly add more things as they learn the platform and everything. Backend developers start with some small part of our serverless backend and then learn more things. Another big challenge was testing. And we picked like a hexagonal architecture at some point to be able to like or ports and adapters, which is different name for this architecture, that allows us to test things more easily. And it's called port and adapters because it works the same way ports and adapters work. So for example, in happy times when we were able to travel, if you travel to Europe or if I travel to the US, I'm not able to plug my laptop in the power socket supply in my hotel somewhere, for example, in Las Vegas or whatever. I need a different cable. So I don't want to buy a completely new cable or laptop or something like that. Instead, I can just buy a small adapter that is really cheap that will convert my type of like a power plug to power socket supply that I have in that hotel. So we want to do the same with our architecture. So our business logic should be completely isolated from everything. And then we have some different like ports and adapters. There's like port for incoming event. So whenever we have this service in production, there's Lambda trigger adapter. And then in local, we can trigger that with some kind of a local trigger adapter or whatever. Let's say that our service need to save some data to a database and then notify someone. Database can be like that. We have database port that can be like we can have like DynamoDB adapter or MongoDB adapter in production, and then some kind of in-memory adapter locally when we run tests and things like these. And for notifications, again, maybe we want to send notifications through that event bridge or SNS or something like that. And then locally, we just want to use some simple local notification adapter that will just allow us to test our business logic. So again, if we go back to our service that I already mentioned and focus on one Lambda function, this Lambda function looks something like this. And now it's just TypeScript for us, but the structure and everything is the same. So we have Lambda TS or JS file that basically wires all the dependencies, and there's no tests for this file. It's really simple. It just like imports all the dependencies and invokes our business logic. Then there's business logic that has unit and integration tests. But as many of our functions are talking to DynamoDB or EventBridge or some AWS services, we don't want to test each of these functions, again, the real services. Instead, we have integration tests with some local notification repository, for example, or local database repository that has the same interface as the real repository. And of course, unit tests are just unit tests. Then we have a real event bridge repository, for example, that has its own unit test and integration test that tests this repository against Amazon Event Bridge. And then we know that this part of the system works for all different Lambda functions. Whenever we want to send something to EventBridge, it will go through the same repository. And then there are some other things like event parser and maybe some other parts that we can share between multiple functions. And sometimes these functions have unit tests, sometimes they have like also integration tests if they're using something externally. Then, as I mentioned, we're often migrating things from one service to another and things like these. I mentioned MongoDB and that we migrated to DynamoDB. Hexagonal architecture helped us with this. It took a lot of time to build like transfer data from one database to another. But from point of the code, our business logic stayed the same. We just like had our MongoDB repository with unit and integration tests. So we built a DynamoDB repository with the same interface, and we simply switched these two. And that was it from the perspective of our code. Our business logic stayed the same, and that's it. And if you take a look at these integration tests, we can do many cool things in AWS. For example, we can create a test database and destroy that test database after we run tests. So for example, if we do something like this, we can, for example, we can put some parameters, create a table, and then wait for that promise to resolve. When that promise resolves, our table is still not ready. So we can have another like event, which is another promise that will tell us when our new table is ready, and then we can run our tests. And in the end, we can just delete that table. And of course, before all, we can also see that table or whatever. We can just remove that table at the end of our tests. And of course, beside these, we have end-to-end tests that are also important for everything. For debugging and monitoring, that improved a lot over time. So with the cool thing with our new event-driven architecture is that we can have like one place now where we can see all the errors in our business logic. We can filter by them. So for example, if I filter everything by error and different errors, I can see who had the error at any point of the running of our backend, maybe in last 6 days or whatever, when the error happened, what are the different errors. We also have some kind of monitoring and alerts. So now we know that Slack is down before they even like announce anything or anything like that. We have a really cool monitoring now that can let us know whenever there are some errors and things like these. And as you can see here, we have concurrent executions up to 1,000 functions in parallel and things like these. There are a lot of invocations from time to time. Yeah, that's it. The cost of the system is really important part when you're a startup. And so the total cost for our app from the very first day we are running this application until today is around $7,500. And we had like $5,000 or even more AWS credit. So we paid like less than $2,500. And I also know how much was the most expensive bug that we had. And I created that bug, and it was like $3,200. So almost half of our total bill from 2018 until today is one bug. And our current AWS bill is for all the environments, including production and all developer environments, is less than $300 per month. It was, I think, 263 or something like that last month. So I mentioned that bug. What I did was there was one check in the app where I changed something, and then we wrote like 250 million. We sent like 250 million requests to our DynamoDB table, like write requests, not read requests. We saved the data 250 million times by mistake. And yeah, basically the cost of that bug was $400 more per month of DynamoDB bill. Everything worked perfectly fine for our customers. We saw that when we run out of our AWS credits, because we thought that we'll have credits for more time. Of course, we have many other small challenges over time, but we're really happy with serverless, and our developers are really happy because they can build like a lot of new things really fast now. For example, we built like a full integration with Google now in less than 1 month. And it was really easy to test that on different environments and things like these. And now we have some developers with superpowers. Basically, they're able to do many great things in production. So I'll do a quick summary, and then we can go to questions if you have any. Of course, while you're evolving your product, you'll need to evolve your architecture. That's a normal thing. It's really important to pick a good architecture that helps you with migrations and onboarding, and keep basically the onboarding cost really low. And for us, CQRS works really well. Also, hexagonal architecture is really one of the best architectures that is actually really simple to implement, that you can use in a serverless app. You need to think about onboarding new team members. It's not just like important to build a smart architecture, because people need to understand how to work with your application. As I said, hexagonal architecture is really nice fit for serverless, not just for our application, but basically any serverless application that I saw. CQRS is also a nice fit for serverless and excellent fit for vacation tracker. I didn't mention, but there are, for example, in CQRS, you want to be able to do replays and things like these. the great thing is that EventBridge can do that out of the box for you. So there are a lot of things that you can outsource to AWS, and you can focus basically on your business logic. And that's why everything works really nice for us with serverless. And of course, it's really important to test your application in general, but with serverless, it's really, really important to test your integrations, because you have really small pieces that are talking to each other all the time. So it's really important to test all of these things. And sometimes testing is not enough, so you need to be able to catch all the errors and have monitoring just to be sure that your customers can use your application at every point without any issues. So I mentioned at the beginning that this is the last thing that I wrote the book called Serverless Applications with Node.js with my friend Alexander Simovic. I have some promo code for 40% off, and I think I can get like let's say three free copies of my book to anyone that let's say three first questions will get a free copy of my book. And you can see more about the book on my website. So go to slobodan.me/books, or you can follow me on Twitter. And I'm also working on a new book called Running Serverless Real-Time GraphQL Applications with AppSync. This book is still like in development, so it's not published yet, but it teaches people how to build the application similar to something that I showed you today with GraphQL and with less actually code, and that scales really well. If you want to learn that, you can go to my website again to this same URL and subscribe, and we'll send you the a notification when the early version of my book, our new book, is basically ready. And that's it for today. Again, if you want to learn more about serverless, you can follow this link, and you'll get updates once a month or something like that from me. And yeah, that's it. We can go to questions now. How do I stop sharing this? Yeah, cool. So I hope the presentation wasn't that boring. So if you have any questions, feel free to ask them. And as I said, three first questions will get the copy of my book. Oh, so I have one question actually in the chat from Kyle. So Kyle asks, do we use any frameworks like serverless framework or something that AWS provides? So at the moment we are using AWS SAM for our infrastructure, but there is no specific framework that we use besides that. SAM just allows us to build like serverless functions and a few other things a bit more easy, instead of like I don't know, instead of writing all these things in pure CloudFormation. But in my book, we are now showing how to do these things in the thing that I mentioned called CDK, or Cloud Development Kit, because it simplifies some things a lot, and it's much easier to test the infrastructure. So if I'm starting from scratch today, we would build this application with CDK. I hope that answered your question, Kyle. You can send me your email or something like that, or you can email me to. I'll write my email here. If you want your free version of my book, just feel free to send an email to the email that I just posted in chat, and I'll send you a copy early next week. So another question from Neil. Oh, thanks. Another question from Neil. Neil says that I'm a product manager in the DC area, and a huge part of our stack is moving to serverless. Any good resources for more basic high levels architecture? Cool presentation, but a little in depth for me. Okay, so there are a lot of resources, but just some of them are covering like migrations and things like this. The problem is that they're mostly like technical presentations. So if you have any specific questions, just feel free to contact me. You have my email. here in the chat, and I'll try to either connect you with some people, or I'll try to help you with like answering some of your questions. That I can talk to people from AWS. They probably have some like good resources for migration and things like this. I have a few things that we learned, like that I don't have a blog post about these, but we learned a few things, and I can send you that via email. For example, it's good to have instead of rewriting everything, it's good to have API gateway in front of your application, and that just acts as a router, so you can gradually move one by one services, and then like you can use like things such as event bridge in the background, so you can connect your existing application to some new services that you built with serverless. So there are some things that we learned that I can share, but as I said, I don't have a blog post about that. We talked about that, but and we are planning to write more about migrations, but the big problem is time, of course. So if you want my book, feel free to send email to the mail that you have in chat. It's probably too technical if you're not a technical person, but you can give that book to your developers if they want it or something like that.
Hey, thanks for the answer. I'm listening. I just want to say thanks for that. Yeah, I'm a little technical. I've dabbled in some backend stuff in the past, but what we're seeing is we've got a big monolith of, .NET kind of stuff sitting in the core, and we're moving to microservices, and we're slowly adding, like, we have Dynamo running and like GraphQL on top of it, and then we're adding
So I would love to hear more.
Yeah,
I would love to hear more. If you want to share more, just email me and we can schedule a call or something like that. I'm happy to help.
That'd be cool. Yeah, we're definitely looking for guidance as we expand. We're also hiring a ton of front end engineers if you happen to be in the DC area, but I know you're looking for developers too, so apply to him first. But if you're in the DC area and you want something local, yeah, thanks.
I'm actually not looking for developers right now, so apply to Neil's company.
Yeah, if you're in DC, we just opened up like a dozen front end React developers, so we'd love to have you. Shoot me a message. Thanks. Yeah, I'll shoot you a message. But for the book, feel free to give that to someone else if someone needs it in this chat here. So yeah, thank you.
Thanks. So there's another question. What reasons prompted the change from MongoDB to DynamoDB? So the main reason wasn't that we didn't like Mongo for some specific reason, but Mongo is not, we don't have a managed service for Mongo. There's something new in AWS called DocumentDB, which is basically a new database with Mongo interface, but it's not fully managed. And actually, it is kind of managed, but you still need to think about scaling, and it requires virtual private cloud that complicates a lot of things. And DynamoDB is really fast and really cheap. So basically, with DynamoDB, what we can do now is we have one big single table for all of our events, and we can have different queries that can like return a lot of different events for one type of, for example, one person in one company or something like that in less than 10 milliseconds, which is really important for us. And it scales really well with serverless and with Lambdas. The problem in Mongo was that at some point, for example, Slack sent us a lot of webhooks, and people are using our application. So we have a big peak of requests, and Mongo wasn't able to scale with all these Lambda functions because there are parallel connections to that MongoDB. So we had like big delays on the application. With DynamoDB, we don't have that because everything scales much faster. And as I said, it's really cheap for us now because everything is fully managed and we pay only for things that we use. So yeah, and as you saw, you can create like a big mistake in your code and write 250 million things that you didn't plan into your DynamoDB table, and everything will still work perfectly fine for your customers. So I really like DynamoDB. There's an excellent book by Alex Debris about like how to use DynamoDB and all the weird things there, explanation for all the weird things there. And if anyone wants to learn more about that, I really recommend that book. So if you want the book, as I said, just shoot me an email and I'll send you a copy. That's it. I don't have any other questions. Do you have any other questions? Oh, how did we get so much AWS credit? So, well, I think we got most of our credits through some product hunt program. Actually, there's like something where you pay some money and you get access to AWS credits and many other things, such as like discounts for some services that we use, like I think Segment, but also like some other services that we used. Also, Mongo Atlas, I think, was one of them. So we got most of our credits through that. And I'm also, as I said at some point, I'm also AWS Serverless Hero. So I met a lot of people from AWS. So sometimes you can get more credits by knowing some people that can connect you to some other people. But there are, I think, both Product and I think, what's the name of that? I can try to remember the name and send you. If you ping me via email, I can send you the link to that service. Basically, you pay some subscription and then you get a lot of AWS credit, but also a lot of other things. And also, I think Segment startup program also can give you some credits or something like that. Yeah, it's really cool for small products. I also have some credits that I can use for like testing things because of that AWS Serverless Hero program. I'm not able to use it for production, but it's really helpful whenever I want to spin up some tests on my environment or whatever. I can use these credits, so that's really useful. Yeah. So I think I have one more copy of the book. So Jorge, I think I read your name as it should. Feel free to send me the email, and I'll send you a copy of my book and also the link to that product hunt service that that can get you free AWS credits. Actually, they're not free. You pay some money, but you get more credits than you pay. Thanks. Any other questions? I'll wait a bit more. If not, thanks everyone for being here on this presentation on Saturday. I really more like in-person meetups, but I really hope that in not so distant future we'll be able to go back to in-person meetups and everything, because then I can meet all of you and learn something about things that you are building. This way is a bit more weird. I'm just talking somewhere in the other part of the world, like in my camera, and then there are some cool people somewhere else listening to me. But yeah, I'm based in Europe, so I'm in Belgrade, Serbia right now, and both of my companies are in Canada, and yeah, they're based in Montreal. Some part of our team is there, and part of our team is here in Serbia. Okay, thank you. Thanks a lot again. If anyone has any other questions, feel free to ping me via email or Twitter or something like that. I'll one more time just if you want to learn more about like serverless apps with GraphQL, I'll paste the link for our new book. It'll take some time to finish it, but if you subscribe, you'll get like first few chapters, I guess soon in the next few weeks. So that's it from me. Thank you very much. Have a nice weekend. That's it. Bye. How do I stop this?